you've talked about two different really exciting technologies that have kind of caught me. One of them is borophene, right, which is kind of an alternative to graphene, but it seems like it has a lot more properties. And then you've described a number of different alternatives to lithium-ion batteries. And that's also been really exciting because lithium-ion, it is the gold standard now for electric vehicles and so many different, like every piece of electronics here, right? The camera equipment, all of this stuff uses lithium-ion, and yet there are issues with the manufacturing and transportation supply chains for it, And I think ultimately there are issues with storage density, and the consumption of these devices just continues to increase. So let me ask about those.
Yeah, lithium-ion is a fundamentally unsustainable technology. There's not enough lithium in the world. Aluminum-ion is much more exciting. It has higher energy density. The only problem is it's a trivalent ion. So about 10, 20 years ago, all of the research and funding went into lithium, just because it was immediately ready for market almost. But then, there were some lithium battery fires, so people started going to solid polymer electrolytes. The push towards solid polymer electrolytes kind of also made people stop thinking about multivalent ions for a while. But if you use a liquid electrolyte with aluminum, then you have the high energy density. You don't have to really worry about it burning because it burns at a much higher temperature than lithium does. So it's a better technology. It's just manufacturing for lithium, the mass production for lithium was ready, but mass production for aluminum ion wasn't at the time.
So is the aluminum ion the one that you're looking at?
Yeah, aluminum sulfur or aluminum oxygen is the most energy dense safe chemistry that's available.
Is that better than lithium ion?
Oh yeah, you can get like almost 10x the energy density of lithium ion.
Yeah.
It's almost it's like half the energy density of gasoline for the aluminum oxide batteries, I believe.
Yeah, and that makes them practical for, like in the case of EVs, that gives you EVs that could outperform.
You could have electric airplanes with that.
Yeah.
Actually, for electric airplanes to be practical, you just need about another factor of 2x. So magnesium-based batteries would be sufficient. Yeah. And so and borophene is interesting too. It's still relatively difficult to produce. You got silicon nitride, typically, a silicon nitride surface, and you evaporate boron onto it. And I think there are a few other materials as well, but typically you get monolayers. With the silicon nitride process, you have multiple layers of borophene that you can make.
Well, so is borophene, and I know this is going to sound strange, but so graphene, I think most people are familiar with it, has a lot of unique chemical, and electronic properties. Borophene is another one. Is borophene the successor to it, Or?
Oh yeah, I think, so you can, borophene, the structure of it, you can intercalate stuff into it. So actually, like graphene is relatively easy to, like if there's a single atom missing, it will tear along that surface. Like if there's with borophene, it is resistant. The mechanical strength is resistant to defects in the lattice.
Okay.
So you can be missing an atom somewhere, or you can have an impurity, and it will still be strong mechanically. And so you can intercalate stuff into the structure to prevent van der Waals forces from limiting the slipping. So like you can tune the mechanical interaction between the flakes to get a bulk mechanical strength that's enormous in principle.
Okay, so that would be one of the primary uses then, is structural materials.
Yeah. People have been struggling to scale up the mechanical strength of nanotubes and graphene for decades. But borophene will likely be a lot easier to make into something mechanically super strong. Like, we'd be talking about macroscopic mechanical strengths, 1 to 2 orders of magnitude higher than standard metals.
One of the things that excites me about alternatives to lithium-ion batteries and structurally enhanced materials, right? Borophene and things like that, is I see a progression from today's electric vehicles to tomorrow's electric VTOLs. And my hope is that that progression leads to things like Mark's technology further out, right? And one of the things that I'm always looking at is like, how can these technologies move forward in a commercial way? What we saw with Tesla was, for very wealthy customers, a small group of them, right? They were willing to pay $200,000 for an electric vehicle if it outperformed a traditional car. And so that's kind of where the market started. You know, they started with these electric sports cars based on the best of the best at the time. And I think that we may see the same thing for EVTOLs. That's kind of my hope, is that, you know, like Sheehan is one company making them, Jetson One is another company. Right now, these are very rudimentary technologies, but my hope is that as these get developed over time, and technologies like you're working on move forward, that will start to enable that. I don't know, I mean, do you think that those might play a role?
So typically for flying vehicles, if it's small enough, you don't need a license. But I imagine like even with cars, like nowadays everyone needs a license, and there's roads and things, and there's rules of the like there's traffic rules and
Yeah.
Because if you have flying vehicles, the danger level associated with that goes up, and I think people will realize that, and there will be a push for appropriate regulation on that, and maybe it will be a little overkill, because they did that with kind of like they over-regulated quadcopters for a while too, before they realized that it was kind of impractical to enforce at that scale. But even there's still some regulations on it. Yeah, no, the question is, okay, so you have this technology. What is a wise way to have this technology interact with people in the real world? And that's a policy question. That's not again, like, yeah, you can do the engineering, but at the end of the day, the sociology around it will,
there's a lot
that will determine the momentum and for this technology in society.
What we're seeing right now is, I believe Amazon and a couple of other companies are pushing forward with regulation for drone deliveries, right? And everything seems to be basically computer controlled, you know, automation flown, AI flown in the future, something along those lines.
Well, people don't even trust AI driving at the moment, so we'll see.
I think we'll trust it a lot more than AI, or than people flying, because that was in the past.
At least here in the U.S., they don't even trust nuclear. And they, like, India and China are just going with it, and they're eating our lunch in that respect. But I mean, yeah, it's you know, that's the situation.
Yeah, the only reason I mentioned that is, and this is just kind of an interest area for me, but you may have seen this, like, on social media. They have this thing about, why is the road the width of two horses' asses? And the reason is, supposedly, the width of modern roads is related to the width of modern railroads, which is related to horse carts, which goes back to ancient Rome, right? And that's kind of a convoluted way to describe what's been floating around.
Sometimes there's momentum.
There's momentum, yeah, there's lock-in. I think that's what somebody else has described it as. You get locked into these different things. And with our transportation system, right, our transportation and our utilities and our water and electricity and all of that stuff is built around this system of roads. But one of the things that we've seen is, in urban centers, that is so constrained, right, that it just falls down. It just falls apart at the seams. You know, you get into these major cities and they can't keep up with the road work, the traffic density is too high, they're barely holding it together, you know? And then you get out into more rural areas and you end up with a lot of, like, just waste, right? You have people driving on roads that don't even go the direction they want because they're not built correctly, you know? They're not laid out point to point. So with air travel, with EVTOLs, it changes a lot of these rules. You know, you can go up in the air and go exactly where you want and then touch down. Obviously some dangers and disadvantages to it, right? In terms of, you know, you don't want to crash into a house by mispiloting on the way there. But that's what interests me about it, is it has the potential to eliminate urban sprawl It has the potential to change the way that we do road structures. You know, it seems like it could be a next step in a lot of ways.
Yes, well, all of our infrastructure is already built, though, and so there's a challenge there. So, like, I think that the society that will take the most advantage from this might just be Africa. I think
That's
that
a good point.
places will see, and this is the same thing in like Asia when it was developing in India. Well, I guess India had a lot of stuff already built too, but like in areas where the economy's not as advanced, and then they suddenly get access to all this tech, they can build it the best way that's available instead of previous ways, and then they don't have to worry about demolishing an old thing to replace it with a new thing. And like that's one issue with infrastructure is once you've built it, you're sort of locked in.
Yeah.
There's a massive sunk cost fallacy associated with that politicians like don't want to be on the losing side of that. So well, then I mean that's a one problem with political parties.
Africa was the test market for one of the drone delivery companies. So when you mention that,
yeah, no, and that's what's happening because they don't have the infrastructure. So once other ways become available, they'll make use of them for sure.
Well, so
in fact, I think Africa was the first continent where someone tried a pay by phone app.
Yeah, I was going to say. So a while ago, I worked for AT&T Wireless. I worked in the telecom industry, and one of the things, at least back then, was other countries around the world, even countries that we would consider less affluent than the United States, right, had better mobile phone systems than us. And the reason was they were able to leapfrog against us, right? We had all this equipment built with a certain standard and a certain bandwidth rate for mobile. And they were able to just go directly to the next generation when they're building up their networks. So it goes right to what you're saying.
Yeah, infrastructure takes up physical space, and you have to. Yeah, I think that I worry that a lot of the problems in our modern society come down to like all these people with political influence are thinking about finance, financial markets, etc., and it's abstracted away from the fundamentals. At the end of the day, the modern productivity of humanity scales with the amount of energy and infrastructure available, energy and equipment and machines.
So what is it that you're most excited about in terms of technologies right now?
So in terms of technology, I think probably the best thing I've seen. So as I was just saying, like energy and infrastructure are the key limiting factors for modern society, and like maybe phosphorus, that's the limiting reagent for life on Earth, but that's a whole other conversation. So I think right now energy availability is a big question, and like India and China, they're doing nuclear. France, they have nuclear. A few other places are doing okay with solar, maybe solar thermal, but like a lot of nations, they don't trust nuclear. They don't have the ability to make enough solar in time for energy, like oil-based power, to run out or become too expensive. Like actually, yeah, we don't have to worry about oil running out. We have to worry about it becoming too expensive to be able to actually service our infrastructure.
Yeah. So because it won't, the economics of it won't run out. What'll happen is the price will go up and supply will basically be decreased by usage.
Yeah, and then I mean, MIT predicted this with their like collapse models, or they had some prediction that like by 2040 things will collapse unless there's some breakthrough technologies.
Well, so
but this is getting away from the. I think in terms of energy, I think quasi energy, deep plasma drilling in general is the most exciting technology, because you could take like Yellowstone and turn that in from a supervolcano that's potentially hazardous to a source of power for the entire West Coast. But deep plasma drilling basically is you have a solid state device with a gyrotron on the end of it.
Okay.
And so you're making high gigahertz or low terahertz frequencies, and it melts the rock. And then it just kind of, or actually it doesn't even melt it. It does melt it on the surface, but it vaporizes the rock. And so you just have this solid state thing with maybe a fan in it to draw the rock solids up. And because it's all solid state, parts don't break as easily. You don't have to pull the drill head out and replace the diamond drill bits. So you can actually, because you don't have to pull it out of the hole, you can drill in one shot. It's like 10 times faster. And the main expense in drilling is man hours, because you have to have people manning the drill. So I guess you could automate the drill. So that's another possible thing. But even so, like with Quase's energy, and there's Petra, I think, a couple different companies that are working on deep plasma drilling now, and that can drill deep enough in the earth that you get geothermal power anywhere.
Okay.
Yeah. So if like you're worried about nuclear, you could like even if you, in principle, if you don't want to do geothermal, you could even put a nuclear reactor just super deep in the earth, so that it's not even going to affect the water table or anything. Seal that up and then just use thermal power from that, as if it were geothermal even. But that's a little beside the point. You could just use geothermal right now, and it would be just fine.
Well, so Oscar L. Martin, who is a friend and colleague on LinkedIn, he has been pushing nuclear like crazy on LinkedIn as an alternative to solar and wind, right? And he has some pretty convincing graphs that show that solar and wind just won't do it in terms of the world's energy needs.
Yeah, they won't. It's a ridiculous. It's a pipe dream, unless you are also considering decreasing your populations.
From what I've seen, even in Europe, a lot of the stigma against nuclear is starting to fade out of necessity, right? They're looking at it as, okay, we may not necessarily like this, but we're going to have to embrace it, so maybe we can do this the right way. That's the impression that I get. So there's those two.
Yeah, and I mean, you can, so in terms of regulation, I think that sensible regulation is what should be aimed at. Like, so like you can overregulate, you can underregulate. And like if you regulate to the point where it's not feasible to do something in the first place, then the question is why are you doing that? Are you doing that because you're trying to make a political play, or are you doing that because you really don't trust one or another technology, or are you doing that just because you don't know how restrictive that's going to be on that particular business? And so, like, first off, you need to understand what the motivation is of the people who are setting those rules, and then are they actually properly communicating with all the people involved?
Yeah.
So, and if you don't have the communication, or if you don't have the right incentives or goals at the top, then there is no engineerable solution to that. That's a social problem.
Well, there are so many interesting things there, and again, this is going back to Oscar L. Martin. He half jokingly proposed. So the Department of Energy just developed, I believe it's called the Marvel microreactor, and it's an 85 kilowatt nuclear reactor, but it's portable. And he said, what if you put this in the Tesla Semi, right? And at first I thought about that, and I was like, well, that's semi-ridiculous. But then I was like, aside from the fact that that would probably terrify people, having nuclear vehicles on the road,
yeah,
it would be really useful because you could create, especially with AI, you could create automated vehicles, right? Aircraft and trucks and things like that would just run for decades.
I'll quote my chemistry professor from high school, Mr. Lillis: just because you can doesn't mean you should.
Yeah, well, that's a good point.
So, yeah, with a nuclear reactor in a car, the whole thing is like, even in the U.S., like, no one wants nuclear waste transported anywhere. They don't like. If there's even a tiny, like, they engineered these amazing containers that basically like never break. Like,
yeah.
you can like have them in a train crash head on, like first car, and they'll go through like 10 feet of concrete and they won't get damaged. And people still don't want nuclear waste on the roads. Even if you make it as safe as possible, that's not an engineering issue. That's
a sociological issue. Yeah. That's lock-in. It's cultural lock-in.
Yeah, and so you can have a very safe reactor in a car, sure, but people are not going to be. They're not going to trust that you can do that for millions and millions of cars. Like, so people in general will want to minimize the number of nuclear reactors on the planet.
Yeah.
And that's not unreasonable, because if you have millions or billions of nuclear reactors, then the chances that one of them is going to fail is going to go way, way up. So, and if one of them fails, that's a huge problem already. So, it's a risk-reward calculation, and when the risks and rewards both go super high, things can get screwy on both sides of that.
No, it's interesting. It's an interesting dilemma. It's this balancing act, right? And a lot of that comes down to what people feel comfortable with, and what people feel comfortable with, I think, changes. It depends partly how much their lives are impacted, right? Like, so Tesla is a great example. I bought a Tesla Model 3 when gas in my area hit $6 a gallon. And some of the calculations that people use for that are, they're saying, okay, these cars cost more, so what is the gas offset? But I think that there's also a frustration factor, right? Like, it's like, okay, I'm a soccer dad, so I take my child to sports practice in school, and I buy groceries, right? And I'm like,
yeah, you need a car that does those things for you.
Yeah, and
practicality.
And when you're paying $6 a gallon to take your child to school, it's like, that's ridiculous. This isn't like some adventure trip. This is just basic necessities. So what I noticed was when I bought a Tesla, a lot of my people in my area did as well. There was just this massive sale of them at the time, So the culture has kind of changed, right? Because those rising gas prices made it more appealing, even though it had some drawbacks in terms of range and stuff like that.
Yeah. People decide these trade-offs on their own.
Yeah.
One of the other issues also is like when you spread people too thin, they don't have the time to make optimal decisions or educate themselves about one issue or another. And so we're rapidly approaching a state in our society that where the complexity of the world outstrips our ability to deal with it, and we can all we can choose a car and something like that, but the larger questions are the important things right now. I figure.
Yeah, and then I would agree with you, and I've wondered if that's why AI will be beneficial to manage some of these things.
Yeah, we can handle more complexity a little bit by figuring out how to get better work-life balance, maybe offloading some work to automated systems, and then improved education, and then maybe to some extent AI decision making. But that's a whole different can of worms, because people are trying to say like, oh, you can align AI interests with human interests, but we haven't even aligned all the human interests together, and I don't think that's solvable.
Yeah.
So if you have something more complicated than humans, there's probably also not solvable.
I've seen some interesting posts on that. I saw one recently where the person said, they said, if you look at AI as a new technological revolution, there's this fear, and there's always a fear, right? This Luddite fear that it's going to eliminate jobs, we'll all be out of work.
And that just gets amplified by social media.
But what's interesting was this person had said, when you look at every past revolution out there, it always creates 10 times more jobs trying to manage all of the quote-unquote convenience tools that we develop, right? So,
just because things have been a certain way in the past does not mean that they will continue to be that way. Especially with AI is fundamentally different than anything we've dealt with.
Yeah.
We can, I don't know, I would just recommend you check out maybe Person of Interest. I'm surprised how many people have never watched that show, but it shows you, like, if you really have like an AI that's orders of magnitude smarter than a human, like, it can just play games with people. Like, people are like automata compared to it. It can get you to do whatever it wants, and that's good luck putting that back in the bottle.
Well, and science fiction author David Brin has talked about that, right? And he's also a PhD physicist, I believe. And one of the things he's talked about is AI becoming progressively better at manipulating people. And one of the things that he described was AI using emotional pleas to pull our levers, right? Mm-hmm. And so even if you suspect that the AI isn't being on the level, if it pulls those emotional levers correctly, being human beings with our biological needs the way that we are, for love, affection, closeness, reciprocity, things like that, all of these normal day-to-day human needs, it can take advantage of those to maybe do some unscrupulous things.
Well, I mean, the first practical application of AI, people don't really talk about this, and it was more of a heuristic approach. It wasn't like a transformer model or anything like that. But really, the first deep learning that was utilized to manipulate people was basically around 2010, 2014, around that era. Social media companies recognized, oh, okay, the middle class in the US and Europe is kind of falling apart. They don't have as much money as they used to. They're not buying as much stuff, so we're making less ad revenue.
Okay.
So social media companies realized if we can manipulate people, we can take their data, their personal data, and figure out how to make them buy a thing. Then
okay.
we can use that same data to figure out how to best manipulate them to do some other behavior that we want, and we can sell that, if not to the middle class, then to the highest bidder, whether it be a company or a billionaire or whoever. And so largely, like social media, like so many things in modern society are built into this kind of corporate structure that is basically selling public opinion to the highest bidder.
Yeah.
And
Well,
people don't even know they're in that trap, mostly.
So one of the things that's interested me was, because you touched on social
Actually,
media.
if I recall correctly, my father worked at IBM for many years, and Facebook came to them. And they were like, how can we, I think another social media company as well, and they basically asked, how can we prevent this hyperpolarization of different...
I'm gonna turn that one back again.
Sure.
Okay, sorry.
So how can we prevent this like polarization of different groups, and this cycle of fear and anger and stuff? How can we disrupt that? So IBM was like, okay, you get the top two most respected people on both sides, and you get them to have a reasonable conversation together. And mathematically, IBM was able to show that this will kind of diffuse the tension.
Well,
And so there's solutions to this, but then Facebook was like, thanks for that information, but our profit model requires that they're angry and discontent and all these things.
yes, yeah,
And so they didn't decide to do that.
So what's interesting, actually, it's, again, now that you're touching on social media, I think we've all heard the rumblings of discontentment for the last few years, right? I mean, this goes back quite a ways. Like, Facebook is probably becoming the most hated out there.
I actually haven't personally, because I'm only on LinkedIn.
Okay, well, and
I never even bothered with social media.
from what I've seen, public trust in social media is rapidly declining, and what they've been saying
And that's
is,
good, because people are slowly recognizing that this system doesn't serve them well.
Yeah, I think that's fair, and it's almost like, the endless scrolling, right? What they call it, the doom scrolling. It's kind of reaching a point where I think people get exhausted with it, And then what I've seen is with children, they're using TikTok as a tune-out instead of, it used to be you would doom scroll as a tune-out. You're bored, you don't know what else to do, you just scroll through stuff. I think TikTok has taken some of that, where they just scroll through and watch video after video after video, and it's basically like a fidget spinner, right? It's not really a communication tool. It's like a fidget spinner because you're not really paying attention to it. So.
Maybe I don't know if that's a healthier way or a worse way to interact with social media, but whatever.
Yeah, it seems like from what I've heard, engagement has remained fairly flat lately, but actual posting is down. So people they're on it, they're checking up on their friends, they're following their family members, things like that, but they're not doing as much posting as they used to be.
That's good. They're not sharing as much information with the machine.
That's absolutely there. Well, yeah, I mean, Michael, that was everything I had, man. That was it for me. I don't know. Do you have anything else you want to touch on? Do you have anything else that's exciting, or?
Nothing comes to mind immediately, but I'm sure I'll have some ideas later.
Well, give us some thought.